Welcome to a new episode of Fact Odyssey. In today's episode, we'll delve into one of the deepest and most fascinating concepts in physics, time dilation. Have you ever wondered how time can speed up or slow down? Is time constant everywhere? The answer might be more complex than you think, and it's tied to Einstein's theory of relativity. In this episode, we'll explore how gravity affects the passage of time, what its implications are in space, and how it might impact us in the future. Let's get started. Introduction to the theory of relativity. Let's begin by understanding the foundation upon which the concept of time dilation is built. In 1905, Albert Einstein introduced the special theory of relativity, a groundbreaking idea that redefined our understanding of time and space. According to Einstein, time is not a fixed concept as we once thought. It can be influenced by the speed of objects and their location in space. In this theory, time and space form a unified fabric called space-time, which can be distorted based on velocity. However, the more complex theory is the general theory of relativity, which Einstein presented in 1915. In this theory, time and space interact with gravity, resulting in effects like time dilation. Space-time and gravity. Now, let's talk about space-time and gravity. According to general relativity, gravity isn't simply a force as Newton believed. Instead, massive objects like stars and planets warp the fabric of space-time around them. Imagine space-time as a sheet of fabric, and whenever you place something heavy on it, it bends. This is how large masses like the Earth or the Sun affect the flow of time. These distortions in space-time create what we call a gravitational field, which leads to time dilation. When we are in an area with high gravity, like near a black hole, time passes more slowly compared to a place further from that gravity. How gravity affects time. Now, let's move on to the most exciting part of this episode. How does this distortion of space-time affect time? In regions with strong gravity, like near a black hole, time slows down dramatically. This has been confirmed through scientific experiments. For instance, when atomic clocks were sent into space aboard satellites, they showed that they ran slower compared to those on Earth. The reason for this is that gravity in space is weaker, so time runs faster. Another example is the twins paradox. If two twins were separated, with one traveling in space near a black hole and the other staying on Earth, the twin who traveled in space would return to find that their sibling on Earth has aged more than they have. This phenomenon is called the twin effect, and it's one of the most mind-blowing applications of general relativity. Time dilation near black holes. Now, let's talk about black holes, one of the most mysterious objects in space. Black holes have such immense gravity that they warp space-time incredibly. If we were to get close to a black hole, we'd notice that time starts to slow down rapidly. At a certain point, known as the event horizon, time almost comes to a complete stop for anything near it. But from the perspective of someone far away, it would appear that the person approaching the black hole is slowing down more and more. Imagine being able to stand near a black hole. Time would pass very slowly for you, but from the perspective of someone far away, you would appear to move at an incredibly slow pace. This is the time dilation phenomenon caused by the immense gravity of black holes. What happens beyond the event horizon? What happens if we cross the event horizon? The event horizon is the boundary beyond which nothing, not even light, can escape. If we were to cross this limit, it would seem like time stops altogether. However, this doesn't mean time truly stops. It means that someone inside the black hole would experience such a radical change in space-time that it becomes incomprehensible. Scientists are still unsure about what exactly happens inside black holes. Practical applications of time dilation. But the effects of general relativity aren't limited to distant space. In our everyday lives, there are real-world applications of this concept. For instance, the Global Positioning System, GPS, relies on the theory of relativity. The satellites that provide GPS data orbit Earth at high speeds, meaning they experience greater time dilation compared to clocks on Earth. As a result, the clocks on satellites must be adjusted regularly to ensure accuracy. Questions still unanswered. Despite all we've learned about time dilation, there are still many questions left unanswered. For example, how can time behave this way when, at its core, it still seems to be a constant concept? And is it possible to use time dilation for time travel? Could humans ever experience this firsthand? These are questions that spark intense debates among scientists, and the future holds more discoveries. Conclusion. And we've reached the end of our episode. This was an explanation of time dilation and its profound effect on space and on our daily lives. This concept remains one of the greatest achievements in physics and one of the most fascinating topics to ponder. If you enjoyed this episode, don't forget to subscribe to the channel and hit the bell icon to stay updated with new content. If you have any questions or topics you'd like us to explore in future episodes, leave a comment below. See you next time on Fact Odyssey.